Alright, today we're talking about the tangent ratio, sine, and cosine ratios. Tangent ratio is a trig ratio. It's based on two sides of a right triangle. Okay, and the tangent is the ratio of the lengths of the legs in a right triangle. It's called the tangent of the angle. And we'll be more specific when we go through some examples with this. Sine and cosine. Sine and cosine are trigonometric ratios for acute angles that involve the lengths of the leg and the hypotenuse of the right triangle. Angle of elevation, when looking up at an object, the angle your line of sight makes with a horizontal line is called the angle of elevation. So when your horizontal line of sight, and then when you look up at the object, the angle between those two lines is the angle of elevation. Angle of depression, from your vertical line of sight, you look down at something, those two lines, that is the angle of depression. Alright, the tangent ratio. And again, ratio, what does it mean? You're comparing two things with a fraction. We have a right triangle, triangle ABC. Alright, here's the leg opposite angle A, BC. Here's the leg adjacent to angle A, AB, and here's the hypotenuse. Alright, so with this, we are looking at angle A here. So we're referencing angle A in perspective from angle A. Alright, so the tangent of angle A is equal to the length of the leg opposite angle A, which is BC, length of BC, divided by the length of the leg adjacent to angle A, which is length AB. Tangent of angle A is opposite over adjacent. Sine. Again, we're using the same triangle. We're looking at the same angle, angle A. Alright, the sine of angle A equals opposite over hypotenuse. Alright, so angle A is here. Sine of angle A is the length of the leg opposite angle A, so length BC, over the length of the hypotenuse, which is AC. Cosine of angle A is adjacent over hypotenuse. So the length of the leg adjacent to angle A, here's angle A, the leg adjacent is segment AB, or length of AB, and then over the hypotenuse, which is still AC. So when we're talking about opposite and adjacent, we never refer to the hypotenuse as opposite or adjacent. Hypotenuse is always the hypotenuse. Okay? Opposite and adjacent refer to a leg. Hypotenuse is always the hypotenuse. Alright, find the tangent of angle S and the tangent of angle R. Write each answer as a fraction and as a decimal rounded to 4 places if necessary. So we'll start with angle S here. The tangent of angle S equals opposite. The tangent again is opposite over adjacent. Opposite 60 over adjacent 25, which is about 60 divided by 25 is about 2.4. Alright, and find the tangent of angle R. So now if we take angle R here, so the tangent of angle R equals opposite over adjacent, 60, which is about 25 divided by 60, 0.4167. Okay? Again, rounded to 4 places if necessary. That one was exactly 2.4, so we stop. This one's not an exact number, we're rounding, 0.4167. Now, the sine of angle U, and again, sine is opposite over hypotenuse. So sine of angle U equals, here's angle U, the side opposite over the hypotenuse, which is about 16 divided by 34, 0.4706. And then we got the sine of angle W. Again, it's opposite over hypotenuse. Now here's angle W. Opposite, so 30. Again, hypotenuse is still 34. 30 divided by 34, 0.8824. Okay, now cosine. And again, cosine is adjacent over hypotenuse. So like cosine of angle S, here's angle S. It's adjacent over the hypotenuse. Side adjacent is 45, hypotenuse is 53. So the cosine of angle S is about 0.8491. Alright, and then the cosine of angle R equals adjacent 28 over 53, the hypotenuse, which is about 28 divided by 53, 0.5283. Alright, find the value of x. Use the tangent of an acute angle to find the leg length. Alright, so what you always want to do in these problems is you have your right triangle here. We have our angle measure, we have our two sides. The side we're trying to find and the side there where we have the value. Here's the angle. Where are the sides in relation to the angle? Here's the angle, this side is opposite, and this side is adjacent. So which trig function uses opposite and adjacent? And that is tangent. Tangent equals opposite over adjacent. So the tangent of 31 equals opposite over adjacent. Multiply by whatever's in the denominator, so we multiply by x. So x times the tangent of 31 equals 17. Alright? Now we're solving for x, and the tangent of 31 is just some decimal. Alright, so it's a number. So you got a number times a variable, divided by the tangent of 31, divided by the tangent of 31. So x equals 17 divided by the tangent of 31. And plug that into your calculator. 17 divided by the tangent of 31. 28.29. Alright. Second example here. You walk from one corner of a basketball court to the opposite corner, one corner to the opposite corner. Right, solve the proportion using trigonometric ratio to approximate the distance of the walk. Alright, so we have this angle measure here. Here's our sides. Okay? Where are the sides in relation to our angle? Here's our angle. That side is opposite, and this side is the hypotenuse. So we have opposite and hypotenuse, which is the sine. Okay? So we want to take the sine of 62 equals the opposite over the hypotenuse. Again, we always multiply by what's in the denominator. So multiply by x. So we get x times the sine of 62 equals 94, because those two cancel. Alright, and again, the sine of 62 is just some decimal number. Divide by the sine of 62. Divide by the sine of 62. So x equals 94 divided by the sine of 62. So 94 divided by the sine of 62. 106.46. And that is feet. Okay? Now, in order to solve these, one thing you do have to make sure, okay, I have my handy dandy calculator here. You have to check your calculator, alright? And you have to check the mode of your calculator. Depending on your calculator, how you check that varies from calculator to calculator. If you have questions on that, make sure you ask. So this calculator here, I go to my mode. Alright, this screen comes up. I see radians and degrees. Okay, when we're looking at these problems here, we're talking about 62 degrees, right? Or we're talking about 31 degrees. Alright, so we want to make sure our calculator is in degrees. Okay? In this calculator, when you have the black around the word, that means the one you have selected. So right now I just unselected degree, and I want to have degree selected, okay? So I have degree selected, I'm in the correct mode, so I was getting the correct answers. Alright? And my keystrokes for those problems, for instance that last one, 94 divided by, and I open my parenthesis, and I put the sine of 62, and then I gotta close that first one there, and then I have to close the other one, okay? And then I hit enter, and I get the 106.46. Okay, and I'll go through in class on how to enter these into our calculators based on what kind of a calculator you have, because it does vary how you enter it in, what kind of a calculator you have. Okay? Alright, next problem. You're at the top of a roller coaster, 100 feet above the ground. The angle of depression is 44 degrees, but how far do you ride down the hill? So here's our angle, the angle of depression. What's our distance that we're traveling? Here's the height, okay? There's our right angle. So where are the sides in relation to our angle? Here's our angle, that's opposite, and this is hypotenuse. So again, opposite and hypotenuse, which is sine. We want to use sine. So the sine of 44 equals opposite over the hypotenuse. Multiplied by what's in the denominator. So x times the sine of 44 equals, those two cancel out, 100. Divide by the sine of 44. So x equals, those two cancel here, 100 divided by the sine of 44, which is about 143.96 feet. Okay, next one here. A railroad crossing arm that is 20 feet long is stuck with an angle of elevation of 35 degrees. Find the lengths x and y. Okay, here's our angle. And here are our sides. Now, in this one we have to solve for x and y. So, if you don't know which trig function to use, let's set them all up. So if I do the sine of 35, that would equal opposite over hypotenuse. Can I solve that one? Yes, I can. One variable. Always multiply by what's in the denominator. So we're multiplying by 20. So 20 times the sine of 35 equals x. Great, just multiply that. So the sine of 35 times 20. 11.47. And that's feet. Okay? Cosine. The cosine of 35 and again, cosine is adjacent over hypotenuse, so y over the hypotenuse, 20. Okay? Yep, we can solve that as one variable. And again, multiply always by what's in the denominator, so we multiply by 20. So we have 20 times the cosine of 35 equals y. So y is about cosine of 35 times 20, 16.38 feet. Alright? So, sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. And the tangent, if we would have looked at the tangent of 35 equals opposite over adjacent. we can't solve that one. Two variables, can't solve it, we're stuck. Alright, unlike this one variable, I can solve. One variable, I can solve. Alright? So like I said, if you don't know which one to set up, set them all up. Okay, which ones can you solve? Okay, I can solve this, because again, sine of 35, it's a decimal. Cosine of 35, a decimal. Okay? So, I will be showing you in class how to set or check the mode of your calculator, as well as how to be entering these problems into your calculator. Alright? Thanks a lot.